Hello and welcome again to another fun-filled adventure in Math with Mr. Sims. This is our test incentive video for test 126, which should be super exciting. This is a coronavirus test. Basically, we're doing this during the time. Now, for some of you guys, just so you know, on the test, there's going to be some of the stuff that I work out on the calculator to show you how to do it, all right? But I want you to know that on the tests, a lot of it will show you the actual screenshot of it after it's done, just in case some of you have had trouble for some reason downloading the emulator. You'll still be able to do the test. So that's the idea behind it. So what I'm saying is the test should be a little bit even easier for you because some of the steps that I do here and show you how to do may actually be already done for you. And you'll see a little screenshot of it on the test, right? So I'm just letting you know that. Without further ado, let's go ahead and begin. As always, we'll take 30 minutes, whatever I can get done in about 30 minutes. So Alexa, set a timer for 30 minutes.
30 minutes, starting now.
All right, so let's rock this like it's 1999. All right, there's my calculator. I've reset it. I've done second plus 712 to reset it. Always a good step for you to do with calculators, okay? Let's go ahead and go on to this. The study compared the amount of indigestion a person received with the amount of super duper hot buffalo spicy wings they ate. It was determined that the relationship between these two quantities was linear. In other words, basically it tries to form a line. The correlation coefficient was 0.97, which is actually really good. Which conclusion can be made based on the findings of the study? Well, based on that, there's a couple things I want to notice. Number one, first thing to notice is that I need to pick a color. I'm going to pick, let's go pink. So the first thing to notice here is that this 0.97, that 0.97 is a pretty strong relationship. And you'll also notice it's a positive number, all right? Remember, the closer something is to a straight line, like if all the data points fall on that straight line, that would have a correlation coefficient of 1. If they're a little bit off that line, but they're really trying to form that line, it's going to be close to 1, but not quite 1. Well, 0.97 is actually pretty stinking close to 1, right? And it's positive, so that tells me it's a positive relationship, which is oh, in fact, we don't even have to worry about the positive relationship here. They just want to know is it strong or weak. And the answer here is that's an actual very strong relationship because it's almost 1. If it was going down, it would have a relationship, it'd be headed towards -1, right? And that would be a negative relationship. But remember, if it was negative, if it was on the line, there would be a very strong relationship as well. So anyway, 0.97, once again, is a strong relationship. In other words, your values are going to go anywhere from -1 to 1. And here's 0, right? If the closer you are to 0, it's a weak relationship, okay? If you're on one of these endpoints here, it's a strong relationship, all right? And the stronger you are to this -1 or this +1, it's very strong, okay? So that gives you an idea. Very strong on both these endpoints, okay? The closer you are to the middle, the weaker it is, okay? All right, let's go ahead and move on to the next one. That was no point in making that a song. I don't know why I did. It just felt right. So, okay, here we go. Pardon me. Don't be alarmed. It doesn't travel through the internet. And I don't think I have it. So as shown in the table below, as a person works more hours per week, the amount of free time they have decreases. Ooh. Yeah, you work more, you have less free time. That makes sense. What is the value that represents the linear correlation coefficient rounded to the nearest thousandth between the amount of hours worked and that person's free time? For this one, I'll need my handy dandy calculator. Let me go ahead and pull that over. All right, handy dandy calculator. You're in. All right. So what they want here is they want to know the correlation coefficient. They say it right here. Correlation, where did that go? They said the correlate. Sorry, this is not being nice to me. They want the correlation coefficient right here, the linear correlation coefficient. That's your R value. So I'm going to get that R value now. The way I'm going to do that is I'm going to come over here. I'm going to pull this over to, what? That's not what I wanted to do. All right, let me try this again, guys. Sorry, I'm working on it. All right, so correlation coefficient. So, no, that's not it either. Dag, nabbit, Sims. That isn't there is what I want. All right, so they want the correlation coefficient, right? So the way I'm going to do this is I'm going to start off by hitting second plus 712, and I already did that. You reset your calculator, right? Then I got to turn on two modes. I have to turn on the stat diagnostics because I want to be able to get my R value, and that's what allows me to get my R value. So turn on the stat diagnostic, second y equals. I'm going to rerun through this step fast because I'm assuming you already watched one of my videos to know how to do it. If you didn't, go back and find that video and watch it so you know how to do that process, because I'm not going to teach it to you over and over again. We're just wasting everyone's time. If you haven't done it, go do what you need to do. So, all right. So now that I have that there, I'm going to go to Stat Edit. I'm going to put in my values. This is going to be my L1 and my L2. So I'm going to go 5, enter, 10, enter, 15, enter, 20, enter, 25, enter, 30, and finally 35 on this side. And then I'm going to go to the next one. This one's going to be 40, enter, 35, enter, 30, enter, 26, enter, 21, enter, 15, enter, and 10, enter. And I'm going to go stat. I'm going to now go to calc because I want to calculate the linear regression, which they told me it is. They said it's a linear correlation coefficient. So I hit enter, linear regression. And I always like to, in this case it's not going to be necessary, but under store regression equation, I always like to hit vars and store it just in case I want to see it, right? So I go to star function y1. Like I said, not necessary strictly in this particular problem, but I like to do it as I have it. So I have negative 0.99 is my correlation coefficient. They wanted it rounded to what number? They said rounded to the nearest thousandth. So to the nearest thousandth, this is tenths, hundredths, thousandths place. This is the thousandths place, so it's actually going to be 0.999 because this 9 here makes that 8 round up to 1. So my answer here would be 0.9. What on earth is that? Sorry, 0.999 is my answer. I am done. Bada bing, bada boom. Next problem. Here we go. A nutritionist collected information about the amount of carnauba wax in various brands of gummy bears. She made a table showing the number of calories in one pack of gummy bears and the amount of carnauba wax in each delectable ursine treat. Evidently, carnauba wax is also used on surfboard. But moving on. Oh yes, ursine, because it's a bear. It's so great. Okay. What was I saying? Okay, write the equation of the line of best fit for the table and the table to the left, round to the nearest hundredths. So what they want us to do is use this data to make a line of best fit. So once again, I'm going to pull out my handy dandy calculator because this handy dandy calculator will help me save me a lot of trouble because it'll give me the line of best fit. Now I'm going to do second plus 712. Once again, I'm going to go to my mode, turn on that stat diagnostic puppy dog. I turn it on. And then I'm going to go second y equals, turn on my stat plot, okay? And I'm going to go stat, edit, and then L1 is 141, 181, 197, 138, 136, and 154. And this one, 303. Oh, no, that wasn't it. Let me try again. 303. 345, 407, 262, 265, and 297. And now that I have all of those values, which are amazing values, by the way, I don't know why I said that. I think they're just because they're gummy bears and they're tasty. All right, so these are the values here. What I'm going to do is I'm going to go back to stat, and I'm going to go to calc this time. And I'm going to go down to, what? Let me try that again. Stat, calc. I'm going to go down to linear regression. I'm going to hit enter. And I'm going to go to store my regression equations just because I like to get in the habit of doing it. I'm going to go to function, store it as y1, and then I hit calculate. All right, so now what I have is I have my value. They want me to come up with the equation of the line of best fit. Well, they already have the y equals there, and it tells me that it's going to be y is equal to ax plus b. This a value is this one, the b value is this one. Now don't forget, they want us to round it to the nearest hundredth. So I'm going to start off by doing y is equal to a. What was my a value? My a value was 2.0. They said round to the nearest hundredths. So this one, so 2.07. So it's going to be 2.07x plus, what's my next one? My y-intercept, what is it? It ends up being negative 13.92. This 2 has to round up though because of the 7. So it's going to be negative 13.93. So actually, instead of this plus sign here, this is going to be oh, I didn't want to do that. Boop, boop. All right. So I'm on the wrong layer here. I want to actually be on my vector layer. Let me move that to the very top here. There we go. So this is actually going to be a minus sign. What on earth was that, Mr. Sims? All right, so this is a minus sign here, okay? Minus, and the value that I want for that, according to my calculator, my handy dandy calculator, my value was what? Where'd it go? Oh no, what happened to my calculator? I'm going to have to do it again, guys, sorry. I lost the screen. No, I'm just going to calculate this time. All right, here we go. So my value is negative 13.93. Okay, so that's 13.93. All right, so round to the nearest hundred. So this right here is my equation of the line. Now, just so you know, if I was a teacher and I wanted to ask this a number of different ways, I could say, what's the slope of it? In which case you would just say 2.07 is the slope, right? Or I could ask, what is the y-intercept? And you would say negative 13.93, all right? So both of those, there's different ways I could answer this question. But this time they wanted the equation of the line of best fit. So that is the equation there, all right? So that gives you the help you need. All right, let's go ahead and move on to the next question. Oh, not that way. Aha, yes. Is there a relationship between the age of a tree and the average radius? The answer is yes, there is, by the way. If so, describe the correlation. So let's go ahead and look at this. We're going to describe the correlation, but we're not going to guess at the correlation here. We're actually going to take our handy dandy calculator and figure out what exactly is that correlation. Second plus 712 to reset that. Then I'm going to hit mode, change it to stat diagnostics on. You should be noticing a trend in what I do by now. Second y equals on, and then stats, edit. I have 1, enter, 2, enter, 3, enter, 6, enter. And then on the other side I have 2.2 and 2.6 and 3.4 and 4.4, and that's it. And then I'm going to hit stat calc, go to calculate, right? And they wanted to know what my relationship is. So in this case, I don't need to see my equation. I'm actually going to skip. Never mind. It's not easy. It's not hard to do. Let's just do it. There we go. Put it in. I stored it in Y1 now just for kicks and grins. And there we go. My R value is 0.98499 and so on, okay? So based on that R value is almost 1, right? Remember, 1 would be a very, very, very strong relationship. Where did my cursor go? That was weird. All right. Hello there. Why are you just acting up, computer? So, okay. I need my pen. All right, so remember, if I have a continuum from -1, right? Here's -1 all the way to 1. The closer I get, if you're in the middle, you're at 0, right? The closer I get to this end is a very strong relationship, okay? So that would be a strong correlation, right? It was at 0.98, which is like right here. This is like 0.98 something, right? So it's very strong, and it's also a positive correlation. So this would be a strong positive correlation, okay? That's it. That's literally all they want you to do in that problem. Let's go ahead and do the next one. 5B. Susan gets a commission on many of the goods that she sells at work. She keeps track of the amount she sells in dollars and the amount she gets in commissions. The table below. And this problem might freak you out because you're used to seeing the tables going up and down, right? But it's the same thing. These are going to be your x values and your y values. The only thing they did was make them go sideways this time, right? So this month Susan sold 155. How many can she? How much money can she expect to earn in her commission check? So just so you know, um, this one we're going to have to do a little bit more work to solve it because they actually want us to essentially find one particular value on that line of best fit. So let's get started then. Just want to make sure I can see it. So I'm going to go second plus 712. You know the drill. Hit that. I'm going to hit mode all the way up to stat diagnostics, which is right here. Turn that puppy dog on. Second y equals. Turn on that as well. And then I go to stat edit. When I go to stat edit, I get 138.7, right? I get 236.91. I get 114.5, 328.63, pardon me, 97.62. And moving over to the left hand side, I get 30.62, 65. When you're typing these in, one of the things you want to do is make sure that the one that's the other one is based off of, right? One of these is an independent variable. In other words, the amount sold, based on that, she gets commissions. So this one's the one that needs to go in L1. That is important. That whichever one you put, pardon me, whichever one you put in the calculator for L1 has to be your X value, your independent variable, the one that you can change willy-nilly, and the other one is based off of it, okay? So just remember that there's a couple problems where that might actually, on the test, you might have to factor that in. Now, I think we were really nice to you and might have even told you, hey, pay attention to which one goes into L1 or whatever, okay, for those problems. But like I said, that's how you kind of figure out which one goes into L1, the one that you can change, and the other one's got to follow it. Does that make sense? So, all right, so here we go. I don't know if moving on. So now I'm going to hit stat. I'm going to hit calc. I hit enter. What? Oh, my bad. Let's try that again. Stat, calc. I go to 4, and then I hit enter. And then I'm going to go down to the store the regression equation. This time I actually need to store it. I store it in Y1, and I hit calculate. Now, when I calculate it, it's going to tell me the equation, but that's not what they want. They want to know if she sold $155. So what I want to do is I'm going to go over to my y equals, right? And you can see it's put it in here for me, which is nice, okay? So now I'm going to hit graph, and I can see my line there. Now what I like to do is I like to zoom stat because I want to see all the points that made up that line shown. So you hit zoom stat, right? And when I do that, I can see all my points here. Now what I want to do is I want to know when she sold 155. So I'm going to trace, and right now if I hit to the right, it's tracing a whole bunch of points, right? It's tracing my L1, L2 points, but I don't want it to trace my L1, L2 points. I want to trace this new beautiful line that I came up with, my line of best fit. So I hit the down arrow to jump to that line. Now you can see here it's showing me that line, right? And I want to go to when X is 155. Now this is how we used to do it in the old school days, but with my Hewlett Packard, if I recall correctly. But the way that you're going to do it, actually, you'll see it doesn't actually land on 155. So the way you handle that is you just start typing in the calculator 155. And when I do that, it jumps exactly to 155 here for me, and it tells me the y value is 44.380222. So 44.38 basically is the amount. I'm going to round to 38 because that's the pennies, right? And we don't need less than pennies. So 44.38 buckaroos is my correct answer. Let me make sure I typed that in right. I did. Yep. All right, moving on. Next problem. Okay, this one. Now, this one, if I recall on the test, you had to be careful with which one was X and Y, okay? Now I'm going to choose this one to be X and this one to be Y, but I just want you to know on the test, I think it might actually be switched, and I think we have a note telling you that. So just watch out for that when you get to this type of problem, okay? Without further ado, the table below, I'm going to make this one here my X values because it makes more sense to me that your gold kind of depends on your height. I don't know, maybe your leadership qualities or something like that. It's completely nonsensical anyway, right? Uh, Ooh, never mind, never mind, never mind. So if a leprechaun has 215 gold coins, what would be his predicted height? So the way we're going to handle this one actually is the way that we handle it on the test as well. We're going to make this X and this Y. Okay? Okay. So let's go ahead and do that now without further ado. So I'm going to pull out my handy dandy calculator. Handy dandy calculator. Where are you at? Here you are. All right. So I'm going to hit second plus 712, and just for me and you, I'm going to go not stat mode. I want to go to mode. I'm going to turn on the stat diagnostics 2 on. When I do that, I'm going to hit second y equals. I'm going to hit enter, enter, and now I'm done. Go to stat edit. I'm going to start typing in my values. Now I'm going to make these my x values. And I'm going to make these. Uh-oh, I'm missing an x value. What the? Okay, I'm going to go work with just these four that I got here then. I don't know what happened to that x value. It just is not there. All right, so here we go. So 48, 56, 36, and 25. All right, let's go to the next side. So let's go with 12, 14, 10, and 6. Okay. All right, so now that I have that, I'm going to go to Stat, Calc, and I'm going to do what's called a linear regression on that. I'm going to go down to store the regression equation because I do need it to figure out the actual point, right? Hit vars, y1, and I'm going to hit calculate. And that's going to put it in y1 as well for me. This is the value. As you can see, it's a pretty strong correlation. Let's go ahead and go to y equals. Not y equals. I actually just need to graph it. I'm going to zoom stat because I want to see all the points that I put in there, all those lovely points. And there's all my points. There's my line. Okay, it looks pretty good, right? So now what they want to do, though, is they want to know for 215 goals. And I'm just going to tell you 215 is not on this graph. So the way I'm going to handle that is I'm going to zoom out. And you know what? Let me show you what happens if I tried. Let's say trace. And let's say I jump down to the line like I thought, and I type in 215 for X. When I type that, it gives me an error. It gives me quit. And the reason why it gives me an error is this. The computer, when it graphs it, go back to graph. When it graphs it like this, it only thinks this part that you can see here is what exists because it doesn't figure out all the values outside of there, right? And so when you're doing it, what you see is what you get. Like it doesn't think there's anything outside of that box. So I have to make it realize, yes, there is a line. That line goes on forever and ever. So I want to figure out what it is when it's 215. So the way I let it know, hey, there's more than just what you see on your screen there, is I tell it to zoom out. So I zoom out. There we go. So I've zoomed out. I zoomed out about 2 times, which should be plenty. If it's not plenty, you zoom out again, right? And so now what I'm going to do is I'm going to hit trace as tracing the points. Now I don't want that. I want to trace the line, which is on now. So now I'm going to type in that that 215 that I was talking about. And now it's on the thing, so it gives me the value. My value is 53.56 inches. All right, or 53.57. Did they say what to round it to? Oh, yeah, you could probably round it up to 54 inches then, or 53.57, whatever, however you want to do it, right? Um, I think in this case, I'm going to round it to the hundredths place, okay? When in doubt, probably not a bad thing to round it to if they don't tell you, right? Or whatever makes sense actually would probably be best because certain things it doesn't make sense to have half of, right? But with inches, you can have part of an inch. So 53.57 is probably the answer I'm going for. 53.57 inches. That is so ugly. I can't tolerate that. Sorry, I cannot. No, no, no. I cannot countenance that. Inches. There you go. Haha, victory's mine. All right, moving on to the next one. Beep, beep, beep. Oop, not that way. Hopefully we're making some good time here. 24 minutes or so into the video or something like that. So hopefully I can get a bunch done for you. Let's go ahead and do this. Oh, I'm not going to be able to get rid of that, are I? That's on a different layer, and I don't know what layer it's on. Oh, no. Moving on. Okay. Moving on. That's not it. I'm sorry, it is going to bother me. I'm trying to get rid of it. Nope. Okay. I will not be able to get rid of that, evidently. Moving on. All right. The relationship of a child's t-shirt size and its length are below. I'll just turn it into a smiley face. How about that? Yeah. How do you like that, huh? There you go. Look at that. Mr. Sims problem solving. Okay, there you go. Now you can't even tell it was a mistake. The relationship of a child's t-shirt size and its length are below. What's the correlation coefficient for this relationship? So correlation coefficient, really easy to figure out here, right? Basically what I'm going to do is I'm going to start. I'm going to hit second plus 7 1 true. You know the drill. Turn on your mode, your stat diagnostic. Turn it to on. Once you get it on, you can move on to the second y equals to get the stat plot on. So you get the stat plot on, then you hit stat edit, you go to stat edit, and you put the values in. In this case, it ends up being what? I'm going to move this just ever so slightly so that I can see that more easily. Go back to this. Yeah, that didn't help me at all, did it? Oh, there we go. So I get 3 and 4 and 5 and 6 and on to the next side. Blah, blah, blah. 14 and 17, 20 and 23. Lots of fun for you and me. All right, so you have some wonderful values in there. You hit stat, calc, go to linear regression, which is 4, and I don't even need it to store this time. I'm going to, once again, I just like to get in the habit, right? That way when later on, when I don't remember how to do it, it's there, right? So what's the correlation coefficient for this relationship? Well, look at that. It's a perfect line. So that correlation coefficient is 1. So the value is 1. Yay! What is that? Mr. Sims, what is that? There you go. So the value is 1. That's actually a perfectly strong positive correlation. You can't get a more perfect correlation than that. Which value of R represents data with a strong positive linear correlation between two variables? So I'm looking for a strong positive correlation. So this one automatically is out because of that negative. No, no, no. This one's also out because of the negative. It's a positive correlation. So remember we talked about the continuum. If you have a continuum, a line all the way from there to there, remember if this is 1 down here and this is sorry, that's -1 down there and this is 1 here and then this is 0 in the middle, right? If you have those, the closer you are to the endpoints is strong correlation, right? The closer you are to this midpoint is a weak correlation. And actually, if you're like anywhere in here, you would say statistically there's no correlation at all if you're in there, okay? In that little spot right there, close to the 0. So anyway, you have strong, so in this case, we want a strong positive correlation. So I'm looking for something really close to 1, maybe like 0.98 or something, 0.92. That would actually work. 1.08 doesn't work because there is nothing beyond the 1. When you're talking these, there's nothing out here. It stops at 1, okay? It stops at 1, guys. So just so you know, there is nothing there. No, no. Why can't it not erase that? That's really going to bug me. Oh, well, okay. I'll just pretend I don't see it, but I totally see it. What's this? What's this? Erase. Oh, erase up to the intersection. That's what I want. No, almost. Why not? Okay, moving on. Because this is just bothering me now. There we go. Well, that didn't work, did it? All right, moving on. So next problem, number 9. State if there appears to be a positive correlation, a negative correlation, or no correlation. So what they want to know is it a positive correlation, which would look a lot like something that looks like this? Is it a negative correlation, which would look something like that? Or is it no correlation, which would look basically like random? Whoa, what was that? Or is it a negative correlation, which would basically just look like random stars in the sky? It doesn't look like it's going up, doesn't look like it's going down, it's just randomness. And in this case here, that looks to me like randomness. All random. Like a monkey chewing on your shoe. See, that was random. Just like this. That's also random. What on earth? Mr. Sims. So random. So this is random. I would say then this is no correlation, okay? If it was positive correlation, we would have seen the points going more like grouping together more, like in a positive fashion, right? If it was negative correlation, it would have gone like this, right? Grouping together in this fashion, like trying to make a line in that way, right? So anyway, once again, this is an example of no correlation. Moving on to the next one. Which graph represents the correlation of its given situation correctly? In other words, which one, when you look at this data, that's like, oh yeah, that's what I would expect, right? So let's think about this way. If you have more monkeys present, should you expect that more bananas will get eaten, assuming there are bananas to be eaten? And the answer is yes. Monkeys, it's a well-known fact that monkeys love bananas. Yay, monkeys. Look at them. They're so cute. And I'm telling you that he absolutely 100% loves bananas. He does. He does, right? So I'm telling you, monkeys love bananas. So this one makes perfect sense, okay? But let me check the other ones to see if they make perfect sense. Winter clothes and monthly temperature. Would you, if the temperature goes up, Alexa, stop the timer. If the temperature goes up, should you increase your amount of winter clothes? In other words, as the temperature goes up, do you have more winter clothes that you're using? And the answer is no. If it's the middle of summer, are you wearing a lot of winter clothes? No, that makes sense. That one's out. In fact, we would expect to see the opposite, that as the temperature goes up, as the temperature goes up, winter clothes would, as the temperature goes up, winter clothes would decrease. Why does that look wrong somehow? Winter clothes, winter clothes. Yeah, that makes more sense. Looks weird though for some reason. I'm not sure why that's. But anyway, that's wrong. So hours studied and grade on the test. As you study more hours, would you expect your grade on the test to decline, right? Let's say I studied 1 hour or 2 hours or 3 hours. Would I expect my grade to really get less? No, that's incorrectamundo. So the only one that actually makes sense is the monkeys and the bananas, right? Hashtag heart monkeys. We all love monkeys. Okay, moving on. All right, I hope that has made a lot of sense to you. Thank you for joining me on the Test Incentive video. It's been a lot of great fun. I do wish you guys the most wonderful time and have a wonderful day.
I've been reading books of old, the legends and the myths, Achilles and his goal, Hercules and his gifts.